Guys, welcome. So hello guys, welcome to Ashutosh coaching channel. Now today we are to going the starting. The chapter name is the nature of radiation and matter. या कैसे the dual nature of radiation क्या होता है. Introduction देते हैं. Dual nature of radiation and matters refers to a fact electromagnetic radiation and the matter exhibits both wave-like and the particles-like behavior depending on the experimental setup. Electron setup की देखो क्या आता है. Electronic emission refers to the release of electrons from a material and this can be occur in several days including thermonic emission क्या होता है electrons emitted from a material due to the high temperature. Field emission क्या होता है electron emitted from the electric field it applied to it. And the photo emission क्या होता है electrons are emitted from the material due to the absorption light. And the secondary electrons emission क्या होता है secondary electrons are emitted from the due to the impact of another charged. वर्क फंक्शन क्या होता है द पेल out electrons from the surface of metal and the certain minimum amount of energy is required. The minimum it is required by the energy is called the new work function of the metal, and the work function is generally denoted by the W and the measured in the electrovolt. Threshold frequency क्या होता है द मिनिमम फ्रीक्वेंसी इज ऑफ लाइट दैट कैन बी इमिटेड photoelectron and from the material is called the threshold frequency or cut off frequency that of the material. Okay, and of that material threshold wavelength kya the wavelength of the light and which can emit photoelectronic and from the material and is called the threshold wavelength and the cut off the wavelength of is material. Okay, इलेक्ट्रोवोल्ट मटेरियल क्या इलेक्ट्रॉन वोल्ट क्या होता है इलेक्ट्रोवोल्ट 1 electrovolt is the energy required by the electron when it has been accelerated by a 1 volt potential differences. 1 electrovolt का वैल्यू होता है 1.6 इंटू 10⁻90 जूल. ये बट यहाँ पे 1.6 इन 6.02 दे रखा है तो उतना फ़र्क नहीं पड़ता है. आप 1.6 भी कह सकते हो 1.6 इंटू 10⁻. ओके, वो माय गॉड कहाँ से लगे वो यस 1090. अब देखो फोटो इलेक्ट्रिक इफेक्ट क्या होता है द फोटो इलेक्ट्रिक इफेक्ट इज अ फेनोमेना वेयर इलेक्ट्रॉन्स आर इमिटेड फ्रॉम मटेरियल टाइपिकल अ मेटल व्हेन एक्सपोज्ड टू अ इलेक्ट्रोमैग्नेटिक रेडिएशन एंड ऑफ अ सफिशिएंट एनर्जी एज अ लाइट. हर्ट्ज ऑब्जर्वेशन क्या होता है हर्ट्ज experiment were designed to investigate the production of the electromagnetic waves by a means of spark discharge, but he noticed that the high voltage spark across the detected loop were enhanced when the emitter's plate was illuminated and by the ultraviolet light. The observation of lead hertz to the conclude the light facilitated the emission of some electrons from the surface of material. The photoelectric effect also showed that the energy of incident and light was the quantized and the meaning that it came discrete unit and rather than being continuous. Leonard observation. He observed that the ultraviolet radiation was allowed to fall the emitter's plate of an e- e- evacuated glass tube and encloses two electrodes and the current flowed and when the ultraviolet radiation was stopped and the current was also stopped. The Leonard observation confirmed that the electrons were being emitted from the surface of the material when thus exposed the ultraviolet radiation and that the kinetic of the unit emitted electrons was dependent on the frequency of the incident light. ओके, उसके बाद देखा एक्सपेरिमेंट ऑफ फोटो इलेक्ट्रिक इफेक्ट देखो द एक्सपेरिमेंटल स्टडी ऑफ द फोटो इलेक्ट्रिक इफेक्ट इन्वॉल्व्स measuring the kinetic energy of the electrons emitting from the metal surface and when the exposed to the light various frequency and the intensities and the following typicals involves such an experiment. Setting up the apparatus. A cathode ray tube or a vacuum tube is used to the perform photoelectric experiment effect and experiment. Photoelectric effect experiment. The cathode is a metal plate and usually made up of alkyl metal as a sodium and or a potassium. That is exposed to the incident light, and anode is a positive electrode placed at a fixed distance from a cathode. Evacuating tube. The tube evacuated to remove any gas molecules that could interfere with the movement of electrons. The illumination the cathode, the light of a known frequency and the intensity of shone onto the cathode and using the electrons be emitted. measuring the उसके कहा गया measuring the photoelectric current क्या होता है. The photoelectric current is measured by applying voltage and across the electrode and the measuring resulting current. Repeating the experiment with the light and of the different frequency क्या होता है. Experiment is repeated with the light of different frequency and the resulting photoelectric current is measured for each frequency. Plotting of result क्या होता है. The graph of the kinetic energy of the emitting electrons versus the frequency of incident light is plotted. From the result the experiment, one can observe that the kinetic energy of the emitted electrons and the proportional to the frequency of the incident light and is independent of the intensity of light. ये हमारा कुछ फोटो है, इस फोटो का ध्यान रखना. इसी में हुआ था फोटो इलेक्ट्रिक इफेक्ट करके दिखाना था. ओके नाउ वॉल्यूम फुल करो इसमें से. आगे बढ़ते हैं. Effect of intensity of light of photocurrent. The experimental observation of effect of showed that the photocurrent remained constant and regardless of the intensity of the incident light, and this means that the intensity of light has no effect on the kinetic energy of the photoelectric current or the photocurrent. The effect of potential and the photoelectric current. The photoelectric current is directly proportional to the potential differences and between the collector plates and the emitter plates. Effect of the frequency of incidence radiation and the stopping potential. एक मिनट हाँ potential. The frequency of incident radiation has a direct relationship with the stopping potential and with the higher frequency leading to the higher stopping potential. Laws of photoelectric emission क्या होता है. Photoelectric emission effect by the described by the following laws. The law of conservation of mass क्या. Total mass of energy photoelectric must be equal to the incident photon minus work function of the metal. Law of action and the reaction क्या कहता है. The the photoelectric electrons are ejected from the metal surface with a certain kinetic energy and which is proportional to the frequency of the incident radiation, the independent of the intensity radiation. The law of threshold frequency. The emission of the photoelectric electrons is only possible if the frequency of incident radiation is greater than the certain minimum frequency called the threshold frequency. Below the threshold frequency, no photoelectric effects are emitted regardless of the intensity of the radiation. The law of stopping potential. The kinetic energy of the photoelectrons is proportional to the potential differences between the collector and the emitter plates. The stopping potential is a potential differences at the which is the kinetic energy of the photoelectrons and is equal to the work function of the metals and the electrons and the stop flowing. उसके बाद क्या है हमारा Einstein photoelectric question क्या है. Einstein photoelectric question is the given by the kinetic energy max is equal to h nu minus phi and the ये जो जान लिया where की in max तो maximum kinetic energy फोटो इलेक्ट्रिक इलेक्ट्रॉन्स है. ओके एंड एस जो है प्लैंक्स कॉन्स्टेंट है. वी वेलोसिटी है. ये जो हमारा फाई साई है वो साई क्या है वर्क फंक्शन है. दिस इक्वेशन इज डिस्क्राइब एज द रिलेशनशिप बिटवीन द मैक्सिमम kinetic energy and the photoelectric electrons and the frequency of the incident radiation. It shows the maximum kinetic energy of photoelectrons increase with the increase in the frequency of incident radiation, but independence of the intensity of light. Particles nature of light. Photon. The photon is a particle of light that was introduced by the Albert Einstein to explain the photoelectric current effect, and it was a fundamental unit of electromagnetic energy and that can be described as a wavelength and duality and meaning in it exhibits both wave like particles and the plot like the बोलते हैं ना particles like behavior. And according to the Einstein photoelectric equation, photons have energy and the equal to the product of Planck's constant and the frequency of the electromagnetic wave, and the particles of light particle nature of light and the existence of photons and the were circummed by the several experiments, and is now an established concept in the quantum mechanics. Okay. उसके बाद हमारा है द समरी ऑफ फोटो पिक्चर ऑफ इलेक्ट्रोमैग्नेटिक रेडिएशन. Radiation is behave as the composed of particles is called photon in its interaction matter. Okay. Each photon has a e is equal to h nu, but each e को h nu कहते हैं, and momentum, and that it travels the speed of light. Okay. And the photon of the particle frequency of or a wavelength has the same frequency, has the same energy E, and hc by lambda. Momentum hc by c is equal to h by lambda. And photons are the neutrals electrically and are the not deflected by the electric and the magnetic field. ओके. चौथा कह रहा है इन अ photon particle collision such as a photon electrons collision, total energy and the total momentum are conserved. the wave nature of matter. The wave nature of matter refers to a idea particles such as electrons and the atom molecules and exhibits like a behavior. De Broglie wavelength. The Broglie wavelength is measured of the wavelength wave like a behavior of particles and given by formula h is equal to मतलब lambda is equal to p by h. ओके. ये क्या है फॉर्मूला उन्होंने दिया था, इसी को ध्यान रखना. और जहाँ पे तो एच जो जानती हो प्लैंक्स कांस्टेंट है, लेमडा जो है वही तुम्हारा वेव लेंथ है, और पी जो है मोमेंटम है, और कुछ नहीं है. अब देखो डेविसन एंड द जर्मन एक्सपेरिमेंट क्या था. अब उसके बाद देखो डेविसन जर्मन एक्सपेरिमेंट pioneering experiment in the field of electron diffraction and the performed by an American physicist and the Clinton Davison and the later German in the 1927 experiment demonstrated that the electrons previously and the considered to be particles and also exhibits wave-like particle properties. In the experiment, in the a beam of electrons was directed towards a crystal lattice, and the electrons diffracted or scattered, forming a pattern similar to that of wave. By the measuring the angle and the intensity of the diffracted electrons, Davison and Germers were able to the calculate and the wavelength of the electrons, and the providing that they indeed and have wave like properties. Thanks for watching video till the end, guys, and you are a part of journey of it. Don't forget like to like, share and subscribe about it, and bye bye and see you next video.